Okay, so moving on to VPComp W, D, and Q, we'll start with this VPCompB and UB instructions. We'll go to the encoder assembly to add some tests. So we've got VPCompB as the first one. So this one takes a K register, which we'll test as K0 with an op mask, so we'll do K4 or something here. Then we've got a vector, so we'll do xmem3. Then we've got another vector, so this is actually RVM encoding, but this one is it's actually got immediates here, but there's no immediate in the operand 4 here. So really this is RVMI encoding, but for some reason they're missing the immediate from the table down here. So RVM, so we've got another vector here, and then we've got I here, which is an 8-bit immediate. So for the other test for this, we just need a memory access, so we'll do RCX here. And then we've got, so this is XMM, YMM, ZMM. So we can just copy these. These are all evex, so we'll just change this to YMM, and then these ones to ZMM. Then we can just copy this for UB. So we'll rename these ones to UB. Then we've got the same thing for W. So we'll just take this one, copy it, and change the B on the end here to W. We'll copy these again for D, but D and Q both support memory broadcast as well. So we'll go to Q here. So W is still RVMI, and then D here still RVMI, but these ones support broadcast in the memory operand. So we'll change this one. So this one should be D, and we'll take all of these memory ones here and just add a broadcast. So we'll do 1's4 for these ones. Because this is D, this should be a 32-bit element size. So when broadcasting, we get 32. You do 1'4 for going into XMEM, 1 to 8. Let's change this one to 1 to 8, and then 1 to 16 for ZMM. Then we should be able to do the same thing for the Q version. So we'll just change this to Q, and because this is Q, the element size is doubled, so we have to halve the lanes of memory that we're the lanes that we're broadcasting into. So this goes to 4, and this one goes to 8. So let's just regenerate the listing there. That looks like it's all okay. Okay, so that's the comparison instructions. I don't think I've missed anything. I think that's all okay. The next ones that I want to do are these VPMOVs for stuff like B2M, W2M, and then there's other ones down here, which is M to something. So this is the mask registers to something, or something to the mask registers. So we'll start with this B2M one here. These are all evex again, but all of these are RM operand encodings. So we'll just go and do VPMOV. We'll start with B to M. So this is K register along with some vector register. So we'll do K2 here, for example, and then we'll do XMM, 6 or something like that. So that's B to M, and there's XMM, YMM, and ZMM for each of these, and then we go W, D, and Q. So we'll change this one to Y, this one to Z. Then we get W. So that's W to M, Each of these has a XYZ, 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 so we'll just copy this one again. This one is D, and then this one is Q. So that's all okay. And then we've got M to some size suffix. This is basically the same thing, but we just switch everything around. So we can take these MOV ones here and just change this as M to whatever this is, and then we can move these to the other side. And then finally, there's this VPMASKMOV instruction here. This one is VEX encoding using RVM and MVR operand encodings here. So we'll start with the VPMASKMOVD. So this is VPMASKMOVD. So starting with RVM, we've got XMM0, XMM1, and then memory access, because this is memory only here. So for D, we've got X and Y, and then for Q, there's also X and Y. So this one is, we can change this to Y, and then for Q, this is also X and Y. Then we have two forms where the memory comes first. So this is MVR encoding. So we'll just take this one, we'll do RCX, and change this to XMM2. Then change these ones to Y. Then we'll do the same thing for Q. Okay, that seems okay, so let's just generate some test notation for this. Just need to check these sizes. This goes at XYZ through all of them as far as I can see. That has broadcasts, so that's fine. So this is XYZ. Then we've got XY, XY, XY. I think that is all okay. So let's regenerate the listing. And we'll take all of these mnemonics over to the mnemonics file. We'll go down all the way to VPMASKMOV. Add these ones above here. Let's just deduplicate them. So we'll separate them out by their rough groups here. So we've got compares as suffixed groups. Okay, so let's take these ones down to the name table. Add the names, and then we'll take these over to the forms table and give them some empty form table entries. Okay, so go test should fail immediately as usual. Okay, so we'll start with a VPCMPB. So VPCMPB here, this is EVEX only. So we'll do family is EVEX. The width we're going to match on here is, this one will be X word. And the op n for this is RVMI. So op1 here is a kreg. And we should allow the op mask as well. Op2 is a vec. Op3 is vec or memory. And op4 is an immediate 8. So for this one we have prefix 66. Map is 0F3A. And the opcode for this one is 3F. Okay, that seems like it's fine. We also need to match on Y word. Oh, and Z word actually, because this is evex. Okay, so now it's on to the UB one. So UB here is the same thing, but it's 3E. I can probably just copy these for the other ones. So let's go to W next. So W is 3F and 3E, but these ones have the W bits set. Okay, now comp D. Comp D is 1F and 1E. It's probably going to be the same for Q as well. And I imagine Q has the W bit set. Okay, so VP comp D, this needs broadcast on the memory for D and Q. Okay, so now we're on to MOV B to M. I'll just copy one of these. So let's find B to M. So this one has RM operand encoding, but there's also, oh no, this is just RM, so that's fine. But this one does have XYZ. So XYZ, this is RM. Op1 can be a K register with no op masks, and op2 can be a VEC. Then there's no op3 or op4. For this we've got a prefix of F3 and a map of 3.8. Then we've got an opcode of 2.9 for B and W, and then 3.9 for D and Q. So this one is 2.9. W is not set for the B one, but it is set for W and it is set for Q. So that's 2.9 and 3.9. Okay, let's just copy these. This one is 3. These two, W has W1 and Q is also going to have W as W1. So now we're on to M to B or M to W DQ. We'll copy these ones over. So this one is going to go MR, but here we're doing VEC as op1 and KReg as op2. So this one is 2.8 and 3.8, and the rest of it seems like it's probably going to be the same. Not quite. F3, 3.8. F3, 3.8 for the, so this is X word, Z word. MR, op1 is VEC, op2 is KReg, prefix is F3, map is 3.8. M to B is 2.8, and then M to W is also 2.8. This one has W sets, this one doesn't. This one is 3.8, and this one does have W set. So what is the problem here? So they're all slightly wrong. Is this a test issue? So M to B, we've got X word with V6 and K2. That looks like it should be okay. Okay. So the actual prefix is correct. This is also correct. The opcode is correct. It's just the mod RM which is incorrect. So what it wants is for I'm getting D6 here, for example. This is getting F2. Is this an operand encoding problem? This one is saying MR. Have I just got the... Oh, these ones are still RM. Okay, yeah. This one is still RM, so we'll just change that. Okay, so now we're on to VPMASKMOVD. So let's go to VPMASKMOV. So VPMASKMOVD, these are all VEX. So we'll change this one to... This one is... family is VEX for this one. The width for this is going to be XMM and YMM. So this is X word and Y word. Then we've got op-n is RVM. So op-n RVM. Op1 for this is, so it goes VEC, VEC, MEM. So this is VEC. Op2 is VEC. And then op3 is memory only. Prefix for this one is 66. Map is 38, so we do map 0F38, and then we've got the opcode, which is 8C. So it's 8C for D and Q. Okay, yeah, 8C for D and Q here. So we'll just copy this one. But Q here gets the W bit set. Then it's the other operand encoding. So let's just copy these down here. So this one is going to be MVR encoding. So this just changes op1 to the memory. And then op3 becomes VEC. So for these ones, it's basically just 8E is the difference here. So this one's 8E, and this one is also 8E. So let's just try that. Syntax error. Okay, so that was just a few extra comparisons and MOVs and things for K registers and stuff like that.